Good evening, all of you. Okay, let's continue from the last time. We had discussed what's the series formula for capacitors, right? So 1 by C equivalent is 1 by C1 plus 1 by C2, and if there are more, then you have to continue in the same manner, right? So that's what we have learned. All right. Now, uh, in this lecture, we are going to talk about parallel, right? What if capacitors are in parallel, right? And then we'll go on to solve some questions, right? Okay, so let's start with that. In here. Okay, so capacitors in parallel, right? So you may have already noted something that in 10th standard for series, you used to have this formula, right? For resistor, correct? But for capacitors in series, we have 1 by C equivalent is equal to 1 by C1 plus 1 by C2 and so on. So now I'm sure you can half expect that for parallel, right? For parallel, because you have 1 by R is equal to 1 by R1 plus 1 by R2 for parallel, in capacitance, we are going to get this, right? So this is the final answer, right? I'm already telling you the final answer, right? Okay, Rudra saying we have to discuss question 24 from exercise. I really don't remember. Let me just check that. Okay, what's that question? We left it incomplete. Is it? I really don't remember. Question 24. Okay, yes, fine. Yeah. Now I recall what was that. Yeah. Okay, fine. Right. Let's talk about that. Fine. So then we'll talk about this parallel later. We have not started about it. Right. So just give me a moment. So first of all, we'll talk about something related to that question 2.24, right, from the exercise. Yeah. We did only. I just want to you know comment on what that is, right? Okay. So, well, the question is that you have to find what should be the area A if you want the capacitance to be 2 farad, right? And I think you would have done it. Can you tell me the answer? What's the answer? I hope all of you have done it. I'm waiting for you to tell me the answer. Area cannot be in kilometer. Yeah. Okay. All right. 1.13 into 10 raised to 9. All right. 1.13 into 10 raised to 9 meters square. Hmm. Okay. Okay. Right. So this is actually a very big area. If you think about it carefully, this is nearly like 10 into 10 raised to 8 meter square, right? Oh, sorry, 10 into 10 raised to 8. So that's, nearly this much. Okay, because 1 kilometer square is 10 raised to 6 meter square, right? So now what this means is this is roughly equivalent to a square plate whose size is this. Okay, see how giant a plate that would be, right? 100 kilometer in length and 10 kilometer in width, right? Obviously, this is an impossible kind of plate, right? You cannot make such a huge plate. It's so big, right? Okay, so what was the purpose of this question? The, this question was given so that you would realize that first of all, this is a very high value, right? This is a very high value, right? That's something which you should understand, right? Okay, the other thing that you need to understand is that here we try to find this area by using the formula for parallel plate capacitor, right? Actually, this is one of the simplest capacitors, right? Simplest as in if you want to do the calculation. But this is not a very good capacitor, right? Generally, you would have seen that in all instruments, whenever you take that capacitor out, it is cylinder, right? Typically, the capacitors are cylindrical. Yes, actually, you're right, right? Farad is a very big thing, right? Okay, so such cylindrical capacitors are normally used, right? Such cylindrical capacitors are normally used. And even then, I hope you remember that capacitor is something where there are two conductors and there is insulator between them, right? And if it is air, it's not a very good it's not going to be a very good capacitor. So what they do is they take two cylinders, one like this, another one like this, slightly bigger, and between these two, typically things like oil or mica, right? I'm sure you know about mica, right? Such things are put or filled inside, right? And that's a very good insulator. So what happens because of putting all this is that the capacitance will increase, right? It will become quite higher. You can actually go, up to easily up to like 10 times higher than with air, right? But all that more details in dielectric. So that's what this bracket is about. However, electrolytic capacitors, right? Electrolytic capacitors are not like this, right? They are such that between two metals there are electrolytes. Okay, so it's all dependent on electrolytes. Okay, do have a much larger capacitance. That is, they can go up to 0.1 farad because of very minute separation between the conductors, right? Obviously, I'm sure you see that here as well. Look at D. If D is small, if D is less, C will be high, right? I'm sure everyone understands that. Yes or no? Right? So even when, see, this is actually very true, right? When the two conductors are close to each other, the capacitance is high. Now, this is actually the right time, is actually the right time to answer a question. If you remember, we took an assumption. We took an assumption that plate is large and the distance is very small. Do you remember that? Right? Okay. So I hope now you realize why it's a good assumption, because if you want decent, if you want a good value of C, if you want a relatively high value of capacitance, then area should be large and the distance should be quite small. Okay, only then it's a good capacity, right? Otherwise, it's not that, it will not be able to store a lot of charge easily. All right. Anyway, so that's all I wanted to tell you about this question. Fine, let's continue with parallel. Okay. All right. So we are expecting this for parallel, right? Okay, and we will get it also, right? Let me tell you the answer before we even start, right? We will get that only, right? So let's start. Okay. So once again, we're going to draw a diagram, right? Circuit diagram. So what does it look like? Well, uh, let's say there's a battery, right, with voltage V. Okay, and we have connected it with two capacitors, one over here, okay, and one over here. And you can see that these two are in parallel, right? This is what you used to do in 10th standard, right? So these resistors were in parallel. So just like that, here the two capacitors are in parallel. All right. Okay. If you don't know how to identify, it's okay. Really, don't worry. I will help you out with that after we finish this topic. In fact, that's obviously on my planned list. All right. So voltage V for the battery. Let's say this capacitor has capacitance C1 and this has C2. I'm short of space in drawing here. Okay. All right. So now, see, this is very crucial. Here, these two are in parallel, right? So if I would take A, B, D, and E, right? Okay. So first of all, let's write down things that you are not supposed to write in paper. All right. You could write this clearly. Okay. All right. Any questions with this? I've written three equations, right? If you have problem with any of these, you could write one, two, or three, whichever. Otherwise, just say yes. All right. If there's a problem with any of these, you could just write down that number, one, two, or three. This is same as what I had explained yesterday, right? Okay, it's almost the same thing, right? Because everything is on a metal wire, right? And we are talking about electrostatics. That's why potential should be equal, right? Okay. So now let's start writing. All right, let's start writing. Okay, fine. So here we go. So you could just write in the circuit shown here, capacitors C1 and C2 are connected in parallel, right? A battery or supply, you can write it as you want, of voltage V is also connected. All right, so this is what we know. Now, what are we going to do? We are going to talk about charges, right? So, charge stored by capacitors is Q1 and Q2 respectively. Now, if you would compare this, I want all of you to compare this with the previous one, that is series. All right. So I'm going to switch over to that. Okay. We'll come back to this. What is happening over here is you can see that the charges, I have taken them to be different, right? But if you look at the voltage, so voltage for first capacitor is this, potential difference is that, right? And for the second capacitor is this, but they are equal and equal to V, that is battery voltage. All right. Okay. So what we are having here is, as capacitors are in parallel, their voltage V1 is equal to V2 is equal to V, right? Okay, right? So you see, this is different. This is different from series. Have a look at this. In series, what we're getting is that Q1 is equal to Q2. I hope you remember that, right? I made you write that over here, this one. Read this sentence, right? Okay. So in series, the charge was equal, but the potential differences were, okay, where did it go? Did I not derive it? Yeah, here. Potential differences were V1 and V2. So this is V1 and this is V2, right? For first and second capacitor, they are different, right? So what happened in series? Charge was same, but potential differences are different. V1 and V2. Voltage is different, V1 and V2. Now in parallel, what we have is, yeah, it's the other way around, right? In parallel, the charge stored is different, right? But the voltage is same, right? So that's the difference. Okay, right? So let's mention this in the diagram as well. Let me just write it here. So this one has plus Q1 minus Q1. This is plus Q2 minus Q2. All right. So that's what it is. Now I hope I hope you remember how capacitors get charged. I'm drawing the same diagram but slightly larger so you'll understand. Okay, it's something like this, right? Okay, it is something of this kind. So you think about at the start. See, like I said, one electron will come from here. It will flow through this battery. Then finally, battery will supply it here. So here you get one negative charge, and here you'll get one positive charge, right? Okay. So if this has charge Q1, that means Q1 charge has flown like this, okay, and gone over there. And similarly, Q2 charge has flown like this and gone over there, right? So if I want to write, okay, so this is something that you should write in your paper. Charge flowing through the battery is, okay, charge flowing through the battery during charging process. Charging means storing charge on capacitor, right? Charge flowing through the battery during the charging process is Q1 plus Q2, and let's call that total charge Q, right? Again, it's simply that if 10 electrons will flow from here, right, and go through the battery, and maybe 20 will flow from here and go through the battery, then through the battery, total 30 electrons will flow, right? So whatever goes from here, from there, so total will be 30, all right? So it doesn't have to be equal, okay, right? So now, because we have Q1 is equal, Q1 plus Q2 is equal to Q, if I want to draw equivalent, so let me write that next step. Equivalent circuit is shown here. All right, so now we will draw equivalent. It is okay if you don't draw this diagram. All right, that was only for example. All right, so this is what we have here. So this is an equivalent capacitor which will do the same job as both of these two did together, right? It will have the same properties as both of these together. So now we can continue writing for equivalent circuit. For equivalent circuit, charge flown for charge stored Q, right? See, it should be the same. Yes, which one? Of course, charge stored Q should be same as C equivalent into V, right? Okay, because they are related by the formula C is equal to Q by V. All right, I hope you realize this is because C is equal to Q by V, right? Okay, now this Q should be equal to total charge stored, right? This one, right? Because if this capacitor is to store charge Q, then charge Q must flow like this through the battery, right? So that's why we are going to just compare the charge flown here and here. So that means this Q should be equal to Q1 plus Q2. Therefore, I can just write, okay, is this okay? Yes or no? Fine. So let's continue from here. Now we are just one or two steps away. It is that V1 is equal to V2 is equal to V. That is battery voltage, right? So if we put it here, we can easily cancel it, right? So final answer or final step will be therefore C equivalent is equal to C1 plus C2. All right, clear? That's that, right? So this is the derivation for parallel. Okay, so now we have finished both of these, and I would expect you to remember the formula, right? Once again, to repeat, for series, you have 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3 as many as there are, right? And for parallel, you have C is equal to C1 plus C2 plus C3 as many as there are, right? So this is exactly the opposite way of how it used to be for resistor, right? Okay, so it's not that tough to remember, right? Okay, now let's solve a question based on this, right? Okay, so well, we have a question. Yeah, question number. Okay, have we solved question 6 from exercise? Have we solved question 6? All right, no problem. First, let's solve 7 because it is about parallel. Okay, so now we are doing number 7. Okay, number 7. Then we'll solve the 6. Okay, so here's the question. I recommend that to avoid confusion, this is actually a better word. All right. Okay. So three capacitors of capacitances 2pf, 3pf, 4pf are connected in parallel. So draw circuit diagram. Come on, everyone. Draw a circuit diagram. I'm giving you 30 seconds to do that. 30 seconds. Call them C1, C2, C3, right? Yes, Aman, correct. All right. So now I hope everyone has drawn a diagram. મને ખબર છે આ બહુ જ easy છે, બરાબર? આ તો ક્લાસરૂમમાં હોત તો હોમવર્કમાં જ આવવાનો હતો આ તો. So this is what we are given, right? Okay, this is C1, this is C2, and this is C3. And battery voltage is 100 volt. Okay, now we have to find equivalent capacitance. So that's a no-brainer. 9 pm બરાબર. આનો આવડે તો કાલથી આવવાની જરૂર નથી, ખોટો ટાઈમ ન બગાડો તમારો, right? So B now, determine charge on each capacitor. Charge on each capacitor means charge stored, right? Everyone understands that capacitor stores charge, એટલે એવું લખે નહીં, right? So charge stored on each capacitor. It means we have to find what is Q1, what is Q2, and what is Q3. Again, the basics are important. These are in parallel, right? In parallel, voltage is same, like I said earlier, right? When I was explaining this, I mentioned it over here. Read this. Okay. Yes, Q is different and voltage is same. So that's why here, if I want to find Q1, what formula should I use based on capacitance? How should I find Q? Yes, very good, Dhawan. What's the formula, people? If you want to find Q? nahi. See, we don't want to find total charge, right? Yes, we should just use Q1 is equal to C1 V1. All right. Okay, but V1 is V. Clear? Yeah. C into V, right? Yes. So what? Oh, just a minute. Yeah. So what will be this equal to? 2 PS, right? Into 100. So that will be 200 picocoulomb. All right. Okay. So like this, you have to find the rest. It's very simple. Okay. All right. So that's it. Now we are going to find out the answer for second. So that's going to be 300, right? And 400. Okay. Let's solve question 7. Question 7. So I'm going to copy it. Meanwhile, you read it. Question 7. Okay, sorry, this was 7. Question 6. I'm so sorry, right? Question 6. Okay. I want all of you to draw a diagram, please. So here we are given 3 capacitors, and each of capacitance 9 PS, right? And they are connected in series. Okay. So I hope you have drawn diagrams. I'm going to follow you. This is what it should look like. Okay. Right? Right? So now we want to find what's the total. Again, this is wrong word. Total is 27 pm. Total means addition, but we don't have to find total. We have to find equivalent. આ લોકોને લખતા ન આવ્યું. So we have to find equivalent. So 1 by C equivalent is equal to so 1 by C1 plus 1 by C2 plus 1 by C3, right? આવડે ને આ કરતા. So final answer is right. Okay. Now second one. Second, what is the potential difference across each capacitor? Means we have to find what is V1 means first capacitor's voltage, the second capacitor's voltage, and third capacitor, right? Now, see, this is actually a very easy question, right? And these are equal values, 999, right? That's why it is going to be equally divided, right? So equally divided, that is, this is 120 and all the three are same. And that's why the value of V1 and V2 and V3 will also be same, right? Because these are equal, right? So that's obviously going to be 40 volt, right? I think you all understand that very well, because V1 plus V2 plus V3 is supposed to be 120. લખવું હોય તો આવું લખજો. Okay, this is written proof. V1 plus V2 plus V3 is equal to 120, but as C1 is equal to C2 is equal to C3, V1 is equal to V2 is equal to V3, right? Therefore, 3V1 equal to 120. આવી રીતે આવે proof. Okay, આટલું બધું લખાય નહીં, એટલો બધો ટાઈમ નો વેસ્ટ કરાય. Okay, but see, this works because all the three are equal, right? This works because all the three are equal. If they were not equal, then suddenly we'd have a lot of problems, right? Okay, and that's what we are going to do now. Let's try this. Okay, so I hope you have understood the question. In series, all right, I forgot to write that, are connected in series, sorry, in series to 12 volt battery. Yeah, yes, Avinash, I noted that. Okay, so I hope you have understood the question, and the diagram should look like this. Capacitors must maintain social distance. All right. Okay. Corona capacitors. All right, you could say that. So first of all, see, I'm not even asking you what's the equivalent capacitance, right? I have not even put that as a question, right? We want, અરે ક્યાં તમે લોકો મંડી પડ્યા. So we are getting 3 different answers already. પેલા મને શીખવાડી તો લેવા દો. We don't have, this is not even asked, right? We are asked what's the charge stored on each capacitor. Okay, તો વધારે પડતી ઉતાવળ ન કરો, right? Let's take it stepwise. Listen to this carefully. First of all, these 3 are in series. So what will be same for capacitors? What is same for capacitors? Can you tell me that? Very good. Charge is same. Okay. So if we want to find charge, then we can just do this, right? Because charge is same. So આ જે ચાર્જ આવશે ને એ જ ચાર્જ બધાનો આવશે, right? This same charge will be equal to Q1, will be equal to Q2, will be equal to Q3. All right? Is this clear? Yes or no? Yes or no? Because charge is same, that's why, right? So this is our plan, right? To find Q1, I'll not do anything else, I'll do this. So find C equivalent, do that. Find C equivalent, and V is already given, right? ખાલી આ જ કરવાનું. 12 coulomb. Darshi, are you sure? Tanay, your answer is wrong. Okay, Avinash. That's right, Devanshi. Continue. Yes, Rajat. Well done. Well done, Srusti. Correct, Jia. Unit lakho, Rutul. Raised to 9, Swarali. Or -9. Himani, unit is wrong. 1 farad નથી, Rutul. 1 PF છે. 1 watt mega unit, people, unit. So clearly 1 by C equivalent is 1 by 2 plus 1 by 3 plus 1 by 6, right? So this is equal to 1. Correct? Addition તો આવડે જ છે બધાને મારા સિવાય. So this is equal to 1. So 12 PC, right? Is that okay? All right. Fine. Capacitance is 1 PF, right? Equivalent capacitance is 1 PF. So this is 12 PC, right? 12 picocoulomb. અરે લખ્યું ને, લખ્યું અમર. શું સમજાવું? અમન, what do you want to understand? અરે યુનિટ તો ક્વેશ્ચનમાં જ આપ્યું છે. Right? 1 P means 10 raised to minus 12. All right. So that 10 raised to minus 12 will go here also. And that means now this is 12 into 10 raised to minus 12 coulomb. So 12 P capital C. All right. Okay, fine. So this is done, right? Okay, this is value of what? Q1, Q2 or Q3? Everyone. Is this value of Q1, Q2 or Q3? Very good. All are same, right? So એક સાથે બધાનો આન્સર આવી ગયો. Now, if I want to find second part, that is voltage, okay, for first capacitor, that is V1. Then do you agree that we could use this relation, right? So V1 is equal to Q1 by C1, right? Okay. All have same value, that's right. Okay, so this is done, right? So what will be this answer? Yeah, very good. Okay, yes, everyone, well done. 6 volt, that's right. 12 by 2 કરવાનું જ ને ખાલી, right? 12 by 2, right? So similarly, what will be V2 for second? V2 is equal to Q2 by C2. That's 12 by 3. That's 4 volt. All right. Okay. I think now all of you. Are Aman 2 no આવે ને? Huh. Right? Yes, correct. I think everyone has understood that. Fine. So this is how you do it if these are different. Clear? Yes, 2 for last. Correct, Priyansh. The last answer is 2 volt. Okay. Fine. I think that's enough. Now, see, these are all very basic questions. Board exam માં આવું જ બધું આવશે. Right? Okay, now let's go to one step further. Right? Let's go to complicated question. No, you can't use capacitor because capacitor will store energy. Now we go to the next the more details, right? Finer details. Let's see. So put the name of topic as follows. How to, no, sorry, important points on series parallel. Okay. Number 1. Okay. So the first question is how to identify. મજાક નથી કરતો. 10th સ્ટાન્ડર્ડમાં તો તમને રમાડતા હતા. બાકી 12th ના સમમાં સિરીઝ પેરેલલમાં ખબર નહીં પડે. Okay. So we need a proper procedure. Let's start. First point. Write it as it is. પછી ટપ્પો પડશે. Okay. So what are the key points here, key things here? Are two. Okay, without any branch or joint between them, right? That's something which you should remember. So what does this diagram look like? Something of this kind. This is, let's say, capacitor 1, and let's say this is the wire that goes from capacitor 1 and here it connects to capacitor 2, like this. And you see there is no branch or no joint or no split. Look at this wire, right? This wire has no split in between, correct? Or no branch. Agreed? Understood? Then these are in series. All right? અને મારાથી બહુ આગળ જવાની ટ્રાય ન કરતા, હજી હમણાં પછી મિસ્ટેક થઈ જશે તમારાથી. ઓકે, જેટલું સમજાયું એટલું સમજાય તો બરોબર. ઓકે, વેરી ગુડ. નાઉ સેકન્ડ પાર્ટ, બી. I know this is very long, but this is perfect. Okay, so what have we written here? I'm saying that suppose there are, I want all of you to draw these diagrams, all right? I hope you have drawn this. પછી તો ભૂલાઈ જશે, પછી આ સેન્ટેન્સનો મીનિંગ એ નહીં સમજ પડે, એટલે એવું ન થવું જોઈએ. Draw the diagram, everyone. Okay, let's go to this one. I'm saying that suppose this is one capacitor and we have drawn its plates, right? And let's say here is another capacitor. And the two plates of this capacitor are connected with two plates of another capacitor. What does that mean? So one plate connected with one plate, correct? And here is another plate connected with another plate, right? And of course this will be connected with something else also, right? Suppose a battery lagaidi, right? So now read this sentence. It says that two plates, plate 1, plate 2, are connected with the other capacitor's plates. Agreed? Right? Without any device in between. What do I mean by that? અહીંથી start કરો, અહીંથી ચાલો આની ઉપર. You can go all the way till here, correct? કઈ આવ્યું વચ્ચે? This joint is not a device. Device નો મતલબ થાય battery, capacitor, resistor, bulb, etc. etc. એવું બધું આવશે, right? This is a joint. It's not a device or a branch. You could say it's a branch. It's not a device, right? So you can go all the way from here to there, all the way from here to there. આવું બે સાઈડ થવું જોઈએ, એક સાઈડ થાય તો ન ચાલે, right? Then these two are in parallel. Clear? Okay. Number 3. Yes, if both plates are connected mutually directly to each other, then they are in parallel. Yes, right? You got it correct. Okay, sorry, C, not 3. Excuse me. C. If neither of above 2, right, then capacitors are neither in series nor in parallel. Okay, then what to do to simplify them? We have other techniques that we will learn later in 3rd chapter. Okay, આ સૌથી interesting હોય, neither in series nor in parallel, right? So now whenever everyone says that if you connect capacitors, right, if you connect capacitors, there are not just two possibilities. નાના છોકરાઓ કહે છે series and parallel, સરસ, right? But you should know that there is a third bigger possibility, neither. Okay, and this is the most important one, right? આ બે તો નાના છોકરાઓને આવડી જ જશે, આ નહીં આવડે જલ્દી. Well, yes, it can be coded. એ બધું 3rd chapter માં આવશે પછી એવી situation, right? It can be possible. બધુંય આવે circuit માં તો. Okay, so remember that there are 3 possibilities: series, parallel and neither. એટલે ઘણા સ્ટુડન્ટ એમ કહેતા હોય સર સિરીઝ માં નથી એટલે પેરેલલ માં, તો એવું ન હોય. ઘરે ન હોય એટલે સ્કૂલે જ હોય, ક્યાંય રખડતા હોય ગામમાં તમે બધા. ઓકે, so it's just like that. Now next point, in series, Q is same, agreed, but V, that is voltage, is added to get total voltage, right? Okay, આ તો પહેલા આવી જ ગયું છે ને, ખાલી રિપીટ કર્યું. Okay, but it is worth repeating. Right? Figure draw હું કરું છું, તમને જરૂર લાગે તો કરજો, not compulsory. Suppose you have it like this, right? Okay, then you have Q1 equal to Q2 equal to Q3 is equal to Q, right? But V1 plus V2 plus V3 is equal to V. Have it the side, right? Okay, now third point. In parallel, Q is added to get total charge, right? Okay, charge is added to get total charge. આનો મતલબ એવો થાય પાછો, right? And what is same? V is same, that is voltage is same. So in parallel, equation will look something like this. You have Q is equal to Q1 plus Q2 plus Q3, but V is equal to V1 is equal to V2 is equal to V3. All right, and V is obviously not equal to V1 plus V2 plus V3. આ બે ઇક્વેશન સાથે ન કરતા પાછા. ઓકે, ઘણાય તો વયા ગયા, વાંધો નહીં. આવા સરસ પોઈન્ટ નો યાદ રાખવા હોય તો કેવું સારું. બહુ તમે ટાઈમ ના પાકા હો. All right then. There was something else also, but I cannot recall it now. Never mind, we'll continue with these kind of things tomorrow. All right, okay, I'll actually send you a homework question. Okay, so you make sure you do it, right? Goodbye.